Next, we will review the basic theory of inverse functions. We start off with a definition of a relation, which is a collection of ordered pairs. There are three ways to define a relation: by table, graph, or equation. Here are examples of three different relations defined using each of the methods. We define a domain as the set of all inputs and the range as the set of all outputs. To find the domain of a relation given by a table, we simply list all the inputs. The domain of a relation given by a graph are the values on the x-axis covered by the graph. To find the domain of a relation given by an equation, we can analyze the constraints of the operations involved in the equation, or we can just read it from the graph. To find the range of a relation given by a table, we simply list all the outputs. The range of a relation given by a graph are the values on the y-axis covered by the graph. Usually we are not concerned with finding the range of the relation from the equation, but when we are, we can just read it from the graph. For every relation, we can obtain an inverse relation by changing the inputs and outputs. For example, for a relation R given by a table, we can easily switch the inputs and outputs to obtain the inverse relation of R. For a relation R given by a graph, switching the inputs and outputs is achieved by reflecting the graph through the line y equals x. And that's how we obtain the inverse relation of R. For a relation R given by an equation, we can easily switch the inputs and outputs to obtain the inverse relation of R. Easy to notice that regardless of how the relation is given, when finding its inverse, the domain of the inverse is the range of the original relation, and the range of the inverse is the domain of the original relation. We define a function as a relation in which for every input there is only one output. To determine whether a relation is a function or not, we use the vertical line test, which states that if there is a vertical line with more than one point of intersection with the graph, then the relation is not a function. From the following three relations, the one on the left is not a function, and the other two are functions. To see whether relations given by tables are functions or not, we check the set of inputs for uniqueness. From the following three relations, the one on the left is not a function, and the other two are functions. To see whether relations given by equations are functions or not, we try to isolate the output variable. If it is possible to do without any ambiguity, then it is a function. From the following three relations, the one on the left is not a function, and the other two are functions. Every function has an inverse relation, but not every inverse relation is a function. We define a one-to-one function as a function in which for every output there is only one input. To determine whether a function is one-to-one or not, we use the horizontal line test, which states that if there is a horizontal line with more than one point of intersection with the graph, then the function is not one-to-one. From the following three relations, the one on the left is not even a function, the one in the middle is not one-to-one function, and the one on the right is one-to-one function. To see whether functions given by tables are one-to-one or not, we check the set of outputs for uniqueness. From the following three relations, the one on the left is not even a function, the one in the middle is not one-to-one function, and the one on the right is a one-to-one function. Figuring out whether a function given by an equation is one-to-one or not can be a complicated process. For the following three relations, we are going to use the graphs. So now, by the horizontal line test, we see that the one on the left is not a function, the one in the middle is not one-to-one function, and the one on the right is a one-to-one function. We define an inverse function as an inverse relation of a function that is also a function. Only one-to-one functions have inverse functions. So how do we find an inverse function? If a function is given by a graph, then we can reflect its graph through the line y equals x to obtain the graph of its inverse function. If a function is given by a table, then we can switch its inputs with outputs to obtain the table of its inverse function. If a function is given by an equation, then we can swap the input and output variables and solve for the output variable to obtain the equation of its inverse function. We discussed the basic theory of inverse functions, including the definitions and some properties.